Okay, third section. I want to talk about stormwater quality and quantity. To me, this is another decision area where local community decisions can have a lot of impact. Now, they have a lot of impact on downstream users. So, so a lot of the there's not a clear system motivation. There's not a clear cost in most cases, either regulatory or economic, for local communities to take care of their stormwater quality and quantity within their budget. Where it does start to become an issue where they need to spend money, they know they need to spend money and it's not extra money, is when that stormwater quality and quantity starts to be an issue within the city system. So some of the climate change precipitation forecasts. So, but there's a couple of situations going on with stormwater quality and quantity, because it's actually in local planning practice, there's quite a bit of work done to try to meet the sustainability condition where the rainfall that falls on the surfaces in the town don't contribute excessive amounts of pollution, or don't contribute pollution to the water, ecological water systems running by. Now, this has received more attention since rainfall events started getting more intensity and duration of rainfall events. So, but basically, starting from the sort of classic neighborhood design point of view, stormwater quality, the quality of the stormwater is affected by the rain falling on pavement and hard surfaces in a town, picking up pollutants, the oil that's dripped out of someone's car, or the squirrel poop, to use another example, or garbage that's, pollutants that are left on the ground. So rain falls down, picks up those pollutants from the surface of goes through the stormwater system, which is typically not treated, and directly out into the ecosystem. And that sort of model of how stormwater flows through an urban system is relevant typically for the up to a sort of a maximum level. So in the Midwest, that stormwater system design is for about a 2-inch rainfall or 10-centimeter rainfall event. So it's a design event that is going to sort of dimension your stormwater systems. And in some places, and we'll talk about this with green infrastructure, in some places there's an effort to make sure that stormwater is treated either typically through what's called green infrastructure means, treated in wetlands prior to it going back into the natural system. Stormwater quantity, which we're seeing increasingly as an issue, is where the rate of stormwater returns to surface water is increased from either the baseline natural or from the design level. So the first level of increase is just because of impermeable surfaces like pavement, or hard surfaces like roofs, or the way people like to make concrete channels so that the stormwater goes away faster. And to a certain extent, diverting stormwater, I think just taking it away from its natural path and into another path. All of those can draw people's attention to stormwater quantity. So where climate change is resulting in increased rainfall event intensity and duration, there's a new natural. So we need a new design level for both of those, both the quality and quantity of stormwater. A sustainable condition, stormwater, human systems are designed to accommodate the actual rainfall without damage to human health or safety or environmental quality. So where are we with Prince George? We've already talked a little bit about redefining the floodplain in Prince George, redefining the 200-year floodplain, which is a land use part of it. But basically, it's not just the water rising in the freshet that Prince George is having some issues with. It's also rainfall overtopping infrastructure, stormwater infrastructure. So it's definitely a present issue for the city of Prince George. You guys already talked about climate change impacts to rainfall, and I've been talking about them, but basically we're getting into the interior part of how we decide about buildings and how we decide about how our communities are organized. The other thing that we have to remember, and maybe I'm restating something I've already said, I'm pretty sure I am, but we have this dynamic system. Things are changing. So we need to make sure that our criteria around supply of water use, that we're not referring to a natural standard, we're referring to a performance standard. What do I mean there? I mean that sometimes in environmental planning, we want things to be natural. Wetlands are a good example. We want wetlands to be natural, we want them to be biodiverse, and we want them to be kind of the way they were. But if you're thinking about incorporating them as part of a system of water treatment and water handling, you're thinking of, it's actually, use the word wetland, but it's actually kind of like a natural designed feature. And so one of the things I learned about those kind of water treatment wetlands, where communities are using wetlands to either treat stormwater or sometimes liquid waste, is that there's like a capacity, and then that treatment wetland has to be kind of replaced because it's built up enough sedimentation or whatever that it no longer has the same capacity as it used to. So when we start to think about some of these, incorporating natural systems into how we think of, I'm getting confused between human and natural. We start to think about some of the functions in relation to stormwater, source of supply. We start to think about some of those ecological human system functions, then we're starting to kind of get away from, as soon as we leave the territory where humans are over here and the environment is over here, we have to start kind of adjusting our traditional way of thinking of things, our settler cultural way of thinking about things is as separate. Start to think of them as intertwined, but then we also have to start thinking about what's our relationship with that system. Maybe that's a little bit theoretical. But back to the point about implementation and local communities. Fundamentally, local communities have budgets. for these things. And so issues that affect these things are going to be top of mind. And there are, for all these things, there is sort of a state of practice and there's a state of best practice. So there's a system by which communities should be protecting their groundwater. There's and so in the case where communities are reliant on aquifers, or where there is some question about the aquifer level for the community, there's aquifer monitoring, and there are these water conservation programs where cities are putting in the data they need to identify leakages and reduce their requirement to produce drinking water much lower, and also some other household conservation ideas like possibly metering, possibly water restrictions, possibly education, or encouraging people not to have lawns and to switch to some less consumptive form of landscaping. So those kinds of programs are very common in local communities. The stormwater systems are becoming more common. There's not, again, as I mentioned, there's not the direct budgetary link typically with stormwater, unless you're starting to see the kind of quantities where you're having flooding in the city. But design standards for stormwater systems are changing very slowly still at this point. There was a phrase in the chapter from the Lurch Reader. I know it wasn't written by Lurch, but there was a phrase called stationarity as a principle is no longer in vogue, or is no longer useful in engineering. But in fact, where I have dug into where stormwater, what's the design rainfall? What does the capacity need to be? How much stormwater are we going to produce? How do we reduce our impermeable surfaces? Anyway, those design questions are often based on 50 years of history rather than basing them on what is the stormwater regime going to be going forward. So that's a state of practice question that I think has to differ by jurisdiction. And I haven't dug into that because partly because I'm not an engineer, but that's a thing I'd like to dig into in British Columbia. I've been digging in on other kinds of infrastructure. So the design standards that I know of aren't really keeping up with climate change, and that's a problem as we build new neighborhoods. The problem, the much more urgent problem that cities are going to have to deal with is that their older neighborhoods and their older infrastructures across the country are designed for a much different stormwater regime. Enter some green infrastructure solutions, which I started to talk about. But in the stormwater context, green infrastructure is things that tend to hold or retain water so that you don't have that rush of stormwater out, taking all the pollutants with it. So they, at the same time as holding and retaining, maybe there's some treatment, maybe there's some plant material in there that takes some of those pollutants out. That term, green infrastructure, can be used in a lot of other infrastructure contexts, but I think it's most commonly used to talk about stormwater systems. And then in sewer collection and treatment is, of course, communities are regulatorily required, depending on their population, to have certain treatment standards. So it definitely affects, it's budget relevant, but they're also required to do certain things. But discharge of contaminants from sewer systems is still an issue for us in water, partly because our sewage treatment methods don't address all the things we creatively put into our liquid waste system. So imagine most of that is somewhat familiar to you. So I talked earlier about what would be a sustainable condition with groundwater. Groundwater protection planning is something that communities routinely do that use groundwater as a water source. So the idea is that your source, that you know, in your land use planning, you identify where your source well is, and you make sure that you have no land uses around it that are likely to produce things that could get into the well or somehow get into the groundwater. So ideally, you will have an impermeable aquifer, like an aquifer that is not in much communication with the ground above. And the only thing you have to protect then is that well going through the geology to it. And if you've got that situation, then you can make sure that your dry cleaners and your large industrial installations and your floodplain are not close to your groundwater well. So it's a less use in places like Prince George that are actually drawing water from a river aquifer, because you're less able to protect a surface influenced aquifer from upstream contamination or from the contamination of land uses at a wide area. So in many towns that are reliant on, like, not Prince George, but there's many towns that use water from river aquifers because they require less chlorination. They're going to have less bacterial contamination because they're separated, but they are more vulnerable to other kinds of regional contaminations. Very hard to protect. But you still want to protect those wellheads from land use threats and from flood threats. Some really interesting things happening in Nebraska and across the Midwest when they had those huge floods 2 years ago. So the Prince George supply wells or river aquifer groundwater wells are not deep ones. So they're going to be related to river water quality and supply. But Prince George has special development permit requirements for developments that are in those vulnerable zones. So they're doing the groundwater protection planning insofar as they can protect those wellhead zones and those water quality zones. But obviously they can't protect upstream. So back to this word green infrastructure, it's a general term for the adaptation of natural systems to infrastructure use for human communities. So I'm giving the stormwater example, but if you think of a watershed itself, you know, all that land that surrounds a surface water supply for a community, that watershed is part of the drinking water supply infrastructure. So you could have a green infrastructure program to improve your drinking water quality by protecting that watershed. So that's another kind of source water protection could be green infrastructure, stormwater treatment could be green infrastructure, sewage treatment could be green infrastructure. There's a good example on the East Coast of a town that has a biological sewage treatment plant. They have a plant. It's more than one plant to treat their sewage. I'm not going to use that beaver example, but it's the ability of communities to protect their watersheds for drinking water treatment in British Columbia is kind of a governance issue. Big places can do it, like Vancouver can protect its watershed, owns its watershed, and medium-sized places will often, medium-sized places with a sort of a contained watershed, thinking of Revelstoke or Nelson, or have much less, they've negotiated, there's a provincial recognition that this is the source watershed for that town. But smaller places often have real difficulty protecting their source water quality from those upstream uses. And back to the stormwater green infrastructure examples that I was talking about: retention ponding, rain gardens, green roofs, permeable paving, that kind of thing. A lot of times, if you were to go looking for examples of green infrastructure, the other things you would see is where communities are linking their recreational plan to what's sort of notionally an infrastructure. Your recreation infrastructure is linked to your water system, is linked to, it's kind of more of a, it can also be used to link the recreational human system with the environmental human system. But I think I've always really liked that concept, because I'm always trying to think of ways for people to see their systems as interconnected, like human and natural systems being interconnected. So any word or concept that allows us to see our connection to the air or water or ecological systems, I think is a very important word. So there's a couple of these right now. Well, I might as well say what some of the others are. There's, I think it's Seashelt and Golden, who are looking at natural asset planning. It's a very similar set of concepts. What natural systems do we rely on? So there's actually a lot of these metaphors right now: green infrastructure, natural assets. The other one's going to escape me right now, that people are currently using to look at that relationship. But the problem for many smaller communities is that the Crown governs typically their watershed area, and the local government jurisdiction only goes just so far. And after that, you get into who is making the decisions, what system makes the decisions for land use planning farther upstream. Okay, thank you.